So very good morning to all. So we'll continue our three equations of motion. So in first part of the three equations of motion, we have seen that how to derive three equations. So here I am once again revising the three equations of motion with the help of graphical method and algebraic method. So here in the graphical method, so graph is required. If you see on the page number graphical method, page number 40, you will see page number 40. So in that, first by using the graphical method, we will get the equation. First equation we will get v is equal to u plus 80. So first equation you will get. So this shows the relationship between velocity and time. The first equation of motion, so the relationship between velocity and time. Second equation of motion, s is equal to ut plus 1 by 2 80 square. Ut plus 1 by 2 80 square, that already I have explained on the PPT presentation. So that first part you will see and you will get to understand. So here this s is equal to ut plus 1 by 2 80 square, that shows the relationship between displacement versus time. Okay, so it's a relationship between displacement and time. So first equation of motion, that shows the relationship between velocity and time, and second equation of motion, that shows the relationship between distance and time. Third equation of motion, that is v square is equal to u square plus 2as. So this shows the relationship between velocity and displacement. So here we are using s and here v for the velocity, s for the displacement, and here if you can write this, you can write in such a way that v square minus u square is equal to 2as. That also you can write. The third equation of motion, you can write v square minus u square is equal to 2as. That also you can write. So that shows the relationship between velocity and that is displacement. That shows the relation between this velocity and displacement. Now this part is completed, and I have mentioned to write that three equations of motion by using the algebraic method. So here page number 42, even in the PPT presentation, in short form, in short way, I have mentioned how to derive first, second and third equation of motion by algebraic method. Okay, so that you can write, and that can be asked in exam also, as already I have mentioned in the video. So I am going for the another important topic, that is the last topic of this chapter. So that is uniform circular motion and linear motion. Before that, if you see on page number 44 and 45, two NCERT questions are given. Two NCERT examples are given. Example number 2 and example number 3. So here example number 2 on page number 44 and example number 3 on page number 45. So these two NCERT examples we have to write in the note. Only these two. Example number 2 and example number 3 only. So page number 44 and 45. So here a train starting from race attains a velocity of 72 km per hour in 5 minutes, assuming that the acceleration is uniform. So first we have to find the acceleration, and second the distance. So first using the equation v is equal to u plus 80. V is equal to u plus 80. So in that it is mentioned velocity. So therefore we will get acceleration easily. So acceleration you will get, that is 0.07 meter per second square. And using the third equation of motion, you will get the distance traveled by the train attaining this velocity. So in that we can use this equation, v square minus u square, because in that mention displacement or distance and velocity. So therefore we can use this equation, v square minus u square is equal to 2as, or directly you can mention, so s will get, that is a distance will get, or displacement will get, that is 2.86 kilometer. So this is example number second. And third example, the same method, but if you come to the second part, the distance covered by the train in time. So please all the students be concentrate whenever they are giving distance or displacement versus time. So here we are using second equation. If it is given velocity and time, we are using first equation. If it is given velocity and displacement together, so we are using third equation. So here in example number 3, first equation we will use, and in second we will use the second equation of motion. So here first and second equation of motion in the example number 3. So now come to the important topic, that is the last topic of this chapter, that is uniform circular motion. Okay, uniform circular motion. If I say, we can do this small activity also. If I take this textbook or any other textbook, so here, what is mentioned here? The uniform circular motion, the body moves in a circular path. So now this is a one body and this at the center. So what will happen? This will move in a circular motion, circular path. Okay, so like this, you can see it will move. Okay, so it will revolve. It will revolve. So body moves in a circular path, that is called circular motion, but on the fixed axis, that you all are aware. So here also when I am rotating this my hand, you see, so from here it will start. Okay, so this is called circular motion. So we can define that when the body moves in a circular path around a fixed point, I am taking this part. Okay, so this is a elbow. So here this part. So this is a fixed point, and then the motion of the body is called as a circular motion. So here we can say that when we are playing with that already one example of circular motion, the boy is using thread and ball, and he is moving that ball in circular motion. So even the fan is also revolving, so there is also we can say that circular motion. Fan is rotating, so in that it's called as circular motion. And examples of uniform circular motion: the motion of the earth around the sun. The motion of the earth around the sun, that is a circular motion. Second, the motion of the moon around the earth, that is also uniform circular motion. Third, so many examples are there. Here electrons also moving around the nucleus. So this is the center of the nucleus. You know that this is the one molecule. So at the center it is a nucleus, and hereby all the electrons are revolving. Okay, so while the electrons are revolving, this is also circular motion. So third, if you see the motion of the tip of our hands, okay, so that is also circular motion, and the motion of the biker on the circular track. So that only you know that in the fair there is a bike. You know that there is the deadly circus, we can say. The bikes are in the well. So it is auto well type of circus is available. So in that also same thing. And stone tied to one point of the thread, and that also can be possible. So here uniform circular motion is accelerated motion, because everywhere acceleration, because it's moving in a straight. It's moving in a circular path. And another thing, if you see about the linear motion, is what the body moves along a straight line. The body moves along a straight line. That is called linear motion. So circular motion and linear motion. Circular motion means what the body moves in a circular path along with a fixed angle, and linear motion the body moves in a straight line. Now, if you understand this is a circular motion. So in that circular motion of the body, the speed of the body in the circular motion, so that will be distance upon time, 2 pi r, that is for the circle, 2 pi r for the circle. So therefore 2 pi r upon t. So this formula we can use for the circular motion. Speed of the body in the circular motion, that is 2 pi r upon t. Okay? So 2 pi r is the circumference of the circle, and this is the time, and this is speed of the body. So here linear motion, the body moves in a straight line. So these are the important things about circular and linear motion. Even you will see on page number 49. So page number 49 you will see the same thing. You will see the difference between linear motion and circular motion is given. So that one by one we will see. First is what the body moves in a circular path around a fixed point, and then the motion of the body is called circular motion. Second, linear motion. It moves along a straight line. Then the motion of the body is called linear motion. So it will move in a straight line. Okay, there is no in the zigzag form. It will move in a straight line. So that's why that is a linear. And second, direction of the motion changes every point. So here sometimes you know that if I go for the circular motion, so direction of the body we can say that it will change. The direction of the body will change, but in the linear motion it will not change because it has to move in a straight line. Then third is uniform circular motion is an accelerated motion. Accel means the acceleration, the speed is continuous, and the linear motion, it is not accelerated, means it is unaccelerated motion. An example of circular motion, that external force is needed to move a body uniformly on a circular path. So that is required, force is required. And linear motion, no external force is required to move a body uniformly on a linear path. Okay, so that just rolling. Okay, gravity is also one of the we can say wall is, suppose stone is we will throw stone from our terrace, so it will come down. So free falling also we can say because of gravity. So it will travel in a, what we can say, so force is not required, external force is not required, it will come down. So here that is unaccelerated motion, automatically it will manage. So uniform linear motion is an unaccelerated motion and circular motion is accelerated. So this is about the difference between circular motion and linear motion. So this is the end of the chapter, and example 1 and 2 we don't have to write. So the things which I have mentioned in this video about the NCERT questions, page number 44 and 45, and here NCERT solutions, I am telling you the questions. If you come on page number 72, please all students see page number 72. Just tick mark the questions which I am speaking. Okay, that questions you have to write. And page also I will speak, so it will be easy for you. And once again we will meet online also. So if any problem will be there in this chapter, you will raise your question and we'll try to explain and we'll try to solve your problems. So page number 100, if you see in NCERT in-text questions, so we are in your textbook page number 72, but in NCERT solution the page number 100 there, so in that question number 1 you will write, question number 3 you will write. Now come to the page number 102. In that question number 2, question number 3, question number 4. Okay, then come to the page number 103. So in that question number 1, question number 2, then question number 3. Then come to the page number 107. In that question number 1 only question number 1. And come to the page number 75 in the textbook. So you can see question number 3. Question number 3. So this is NCERT questions, NCERT solution questions. Now come to the NCERT exercise. NCERT exercise, page number 75. Question number 1. Question number 1 we have to write. Then question number 4, page number 77, that we have to write. Question number 1 and question number 4. Then question number 6 we have to write. Question number 6, graph no need to draw. Okay, here graph is not required, or you can do one thing. Just leave this question. Question number 6 we are not writing. So only in exercise we have to write question 1 and 4, and page number 79, question number 7. Page number 79, question number 7. Then page number 80, question number 9 and question number 10. Okay, question number 9 and question number 10 you have to write. If you see last question, an artificial satellite is moving in a circular orbit of a radius 42,250 km. Calculate its speed if it's take 24 hours to revolve around the earth. So here radius is given, time is also given. We have to find the speed in the circular motion. The circumference of the circular orbit divided by time. So 2 pi r upon t. 2 pi r, this formula we will use. So 2 pi r upon t. So by keeping the value, you will get 1.1 into 10 is to power 4 kilometer per hour. The speed of the satellite around the earth. Okay, so these are the questions you have to complete, and we will meet on a Zoom meeting online. Again we will meet on a Zoom meeting from coming class. So if any doubt would be there regarding this chapter 1, so you can raise question. Again I will quickly revise this chapter. If any doubt at that time, you are supposed to ask. Okay, so thank you, have a nice day. If any problem regarding this chapter, again and again I am telling, please raise your question. Okay, then it is possible to solve your problems. Otherwise you will say that I don't understand, this happened, that happened. That is not acceptable afterwards. So clear? So when we will come, when we meet on Zoom meeting, so this wait for 1 or 2 days, will come on a Zoom meeting also, and will do the direct conversation. So that time if you have any problem there, you are most welcome, and we will have discussion. Thank you, have a nice day. Please complete your work and submit of chapter number 1 of chemistry and chapter number 1 of physics also. These chapters we have completed, chemistry completed, even today we have completed physics 1 also, chapter 1. Okay, so motion we have completed, and I have given this part to write equation 1, 2, 3 by taking the PDF PPT presentation. If you know that is given, that is already I have explained on video in first part of the video. So today only I will send you, so that you will see, and remaining if any question then you can ask. Thank you, have a nice day.